Now let's talk about when we perform the two sample independent z-test. So we have already learned how to perform the independent sample t-test, and there are two ways to measure the independent sample t-test. One is where the sample size is equal, and other is the sample size is not equal. Sample size is equal or not equal, it is concerned when we are trying to find out the degree of freedom. In case where the sample size are equal, in that case we will find the degree of freedom by using a simple formula, that is n1 plus n2 minus 2. But if the sample size is not equal, then we need to use a bigger formula, which was shown in the last video. So now let's talk about when we perform the independent sample z-test, or the two sample z-test. So two sample z-test, as it is concerned, that when we perform the z-test, when we know the standard deviation of the population. When we know the standard deviation of the population, then only we will perform the z-test. And same goes for the two sample z-test also, two sample independent z-test also. So in the previous example, we don't know the standard deviation of the population. We know the standard deviation of the sample, but we don't know the standard deviation of the population. If we know the standard deviation of the population, then and if we want to know the whether groups are statistically and significantly different from each other or not, then we need to perform the independent two sample z-test. So let me give you an example so that you can understand. So here is the problem. Suppose it was established that an average IQ of science student and commerce student is significantly similar. Standard deviation of IQ score of science student is 8.2, and in case of commerce student it is 7.9. To prove it, whether this assumption is true or not, one researcher has studied on 22 students. He has collected IQ from them. Among 22 students, 12 of them are from our science background and 10 of them are having the commerce background. The mean of IQ student is 89.2, and in case of commerce student it is 86.5. Prove whether the established fact which says that IQ of science and commerce student is significantly similar at some significant level. Actually, at some significant level is not written here, it should be there. At some, suppose at some 95% confidence level. So in that case we need to perform the two sample z-test. Why two sample z-test, why not t-test? Because we know the standard deviation of the population. Here you can see standard deviation of IQ score of science student is 8.2 and commerce is 7.9. So standard deviation of what? Standard deviation of the whole science students. So whole world, whole countries science students is the standard deviation is known. For that reason we will perform the z-test, not the t-test. If we don't know the standard deviation of the population, so then we need to perform the t-test. But if we need to do the t-test, we need to know the standard deviation of the sample. So let's find out. So first thing is that state the null and alternative hypothesis. So our null hypothesis will be that population mean will be the mean of the mean of IQ of science student is similar to the mean of IQ of commerce students. So that will be my null hypothesis. And what will be my alternative hypothesis is that they are not similar. They are significantly different from each other. So let's write it down. So our null hypothesis is mu1 equals to mu2. So this is our null hypothesis. And what will be my alternative hypothesis? Alternative hypothesis will be mu1 is not equals to mu2. So that is my alternative hypothesis. So that's how we formulate the null and alternative hypothesis. Then step 2 will be state the alpha level. So our alpha level, as I have already mentioned that in the question it should be mentioned the alpha level. So our alpha level is 95%, is alpha is 0.05, as we want to see whether they are significantly different or not at 95% confidence level. So our alpha will be 0.05. So in the z-test we don't need to calculate the degree of freedom, and also we don't need to state the decision rule. So we will directly perform the z-test. So formula of so first I will write down the formula of z in case of two sample t-test. So formula of z is x bar 1 minus x bar 2 minus mu1 minus mu2 divided by sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. So it looks similar to the previous example. Only difference is that here we are using the value of sigma. So value of sigma means previously it was used s1 squared and s2 squared. So what is the meaning of sigma 1 and sigma 2? So sigma 1 means the standard deviation of population 1, which is 8.2, and sigma 2 is the standard deviation of population 2, which was 7.9. And we know the value of mu1 and mu2, as we are assuming that mu1 equals to mu2, so we can say that mu1 minus mu2 equals to 0. So mu1 minus mu2 will be 0. And we also know the n1, the value of n1 and n2. N1 is the sample size, is the first sample size, which was 12, and n2 will be the second sample size, which was 10. So we know the value of sigma 1, sigma 2, n1, n2, and we also know the x bar 1. X bar 1 is the first sample mean. For first sample mean was 89.2, and the x bar 2 was the second sample mean, and it was 86.5. So x bar 1 means the first sample mean, which was 89.2, and x2 means the second sample mean, which was 86.5. So let's find out the value of z. So value of z will be, so again I will write down the formula. So x bar 1 minus x bar 2 minus mu1 minus mu2 all divided by square root of sigma 1 squared n1 plus sigma 2 squared divided by n2, and then I will simply put the value of those things. So x bar minus x bar 2, that will give 89.2 minus 86.5 minus 0 divided by root over sigma 1 was 8.2, so 8.2 squared divided by was 12, and the sigma 2 squared will be 7.9 whole squared divided by n2. The value of n2 will be 10. So that will ultimately give 0.7488. So let's find out whether the groups are significantly and statistically different from each other. So to do that, we should go to the Z table. So how to see the Z table? Let's find out. So here you can see this is the Z table. These are the p-values. So in case of Z table, we need to find out the p-value. If the p-value is less than equals to alpha or 0.05, then we can say that groups are significantly different from each other. So for that reason, if the p-value, we need to find the p-value. If the p-value is higher than alpha or 0.05, then we can say that groups are not significantly and statistically different from each other. So we need to find out the p. So before finding out this p-value, where to locate the actual p-value, we need to perform the Z test. So we have already performed the Z test, and we have the Z statistics. So here you can see it's said 10th and it is saying 100th. So these are basically the Z score. So the 10th place, it is running vertically, and the 100th place is running horizontally. So if I got 0.57 Z score, then at that moment, what will be my p-value? So first I will go to this column. I said my Z score was 0.57. So first I will go to that. I will follow this line, this row. So 0.5, and then a value of 0.07. So the intersecting point will be this. So 0.5686, 56868. So this is the intersecting point of this column and this row. So 0.5 plus 0.07 will be 0.57. Suppose I have 1.11 Z score, then what will be my p-value? So 1.11. So that means I need to add 1.1 plus 0.01. So that will become 1.11. So I will follow this row as it is saying that it is 1.1, and then I will follow this column because it is saying 0.01. So 1.1 plus 0.01 is 1.11. So it is, the p-value is 0.267. So in that case it is not statistically and significantly different.
So our Z score was 0.7488. So I will find point 0.7, and I said 7488, so I will find 0.04. So it is the 0.04. So 7 and it's 0.04. So p value is somewhere between 0.45 to 0.453, I mean 0.459 to 0.453. So it's certainly higher value, higher than 0.05. So we can say, according to our Z score value, groups are not statistically and significantly different from each other, as the p value is higher than alpha, that is uh, 0.05. If the p value is higher than is lower than 0.05, then we can say that groups are statistically and significantly different from each other. But as the p value is higher than 0.05, so we can say they are not statistically and significantly different from each other. So p value in this case is 0.45930.
So now let me show you different steps involved in the z-test. So that was our problem. First I need to mention one thing, that these are all fictitious data. These are not real data. So the question is like that. Suppose it was established that average IQ of science student and commerce student is significantly similar, where the standard deviation of IQ score of science students is 8.2 and commerce student is 7.9. To prove it, whether assumption is true or not, researcher has studied on 22 students, and he found that among 22 students, 12 of them are from science background and 10 of them are from the commerce background. The mean IQ students is given and the commerce students is given. So I need to prove whether the standard, whether the established fact is correct or not at 95% confidence level. So here is the thing, we need to do the z-test because the standard deviation of the population is given, not the standard deviation of the sample is given. So as we know the standard deviation of the population, for that reason we need to perform the z-test. So these are the steps. State the null hypothesis and alternative hypothesis, choose the alpha level, then find the critical value of z in a z table. I have already shown how to see the z value. Then calculate the z statistics. I have already mentioned how to do the disease statistics. And lastly, compare the test statistics and the test statistics to the critical value and decide if you should support or reject the null hypothesis. So one by one. So first one is the state the null hypothesis and alternative hypothesis. So null hypothesis was according to is mu1 equals to mu2. So according to hypothesis, IQ of science student and IQ of commerce student is not significantly different. They are significantly similar. So that's what the assumption was made. So so mu1 equals to mu2. So that was our null hypothesis. We need to prove it whether it's true or whether it's wrong. Second, then we need to formulate the alternative hypothesis, and alternative hypothesis is showing exactly the opposite, which says that those two populations IQ is not similar. So IQ of science student and IQ of commerce student is significantly different. So it is saying they are not different, and alternative is saying they are different. So we need to see which one is correct. Then choose an alpha level. So if you go back to the question, you can see at 95% confidence level. So it's very easy to calculate the alpha level. We want to see 95% confidence level, so the alpha will be 0.05. So if we want to see the confidence level 98% confidence level, then at that time alpha will be 0.01. And next, find the critical value of z in a z table. So I have already mentioned you that how to find the p value in the z table. To make it more easy to grasp, let me tell you that at 95% confidence level, the critical value of z is 1.96. So 95% confidence level, so the p value is 0.05. So if we want to get the p value 0.05, then we need to have the z score of 1.96. And if we want to see at 99% confidence level, then the critical value of z will be 2.58. So this thing will easy to grasp, because you don't need to find the p value in the z table. All you need to look whether the z score is less than 0.196 or higher than 0.196. So higher than 1.96 will be regarded as the lower p value, that is lower than 0.05 p value. And next is the calculation of the z statistics. I have already mentioned this formula is used to calculate the z statistics. X bar 1 and x bar 2 is the mean of the two sample, and mu 1 and mu 2 is the mean of the population. So mu 1 minus mu 2 will be 0, because we assume that there is no difference between mu 1 and mu 2. For that reason, the difference will be 0. And divided by root over sigma 1 squared divided by n1 sigma plus sigma 2 squared divided by n2. So sigma 1 is the standard deviation of the population. Standard deviation of the population 1, that is the science student, and sigma 2 is the standard deviation of the population 2, that is the commerce student. So whole commerce student standard deviation is sigma 1 and sigma 2. So as we know the sigma, so that's why we are conducting the z test. So here is the thing. So x bar 1 is the first sample mean, is 89.2. Second sample mean is 86.5. First sample size was 12 and second sample size was 10. So sigma is the standard deviation of the population, first population, and standard deviation of the second population. And as I already mentioned that mu 1 is the first population mean and second population mean. And with the help of this formula, we have calculated our z score, which is 0.7488. So that's our z score. Then the next step will be compare the z statistics and the critical z value and decide if you should support or reject the null hypothesis. So the test statistics is 7.7488 and the critical value is 1.96. So critical value if z is higher than test statistics. So you can easily see that 1.96 is higher than this. So we can say that test statistics does not fall on the rejection region. So rejection, falling on the rejection region is when we say it falls on the rejection region when the test statistics score is higher than 1.96, then we can say it falls on the rejection region. So now what is the meaning not to fall in the rejection region? So it means we fail to reject the null hypothesis. We are accepting the null hypothesis, which states that there is no difference between IQ of commerce student and IQ of science students. So that's our null hypothesis. So for that reason it is, we can say that we are accepting the null hypothesis and we are rejecting the null hypothesis, as the IQ of two groups of students are not statistically and significantly different from each other. So that's how you conduct the z test, and these are the different steps to follow the z test.